In this module, we'll connect identity and KYC to real-time behavior. You'll see how transaction monitoring pipelines are designed, how alerts turn into cases, and how investigators actually work them. Our focus is on high-volume architecture, data flows, and the key points where you can safely apply real-time blocking. Think of an eKYC and AML platform as a data pipeline with four main responsibilities. First, it continuously ingests data from many sources: core banking, payments, prior KYC and CDD, plus sanctions lists. Second, it normalizes and enriches that data, both in real time and in batches. Third, it turns enriched events into risk decisions using rules engines and machine learning. And finally, it converts those decisions into operational actions: alerts, investigator cases, and regulatory reports. In any serious KYC or AML platform, raw ingestion immediately splits into two analysis paths. The real-time stream is about seconds. Events are scored as they arrive, ideal for fraud checks and sanctions screening, where you must decide before money moves or an account is opened. The batch path is about depth. It aggregates months of activity to uncover behavioral patterns and AML typologies that no single transaction reveals. Robust architectures deliberately combine both views for every identity and account. In a real-time onboarding or AML flow, every event first lands in a message queue like Kafka or Kinesis that decouples producers from consumers and smooths traffic spikes. An enrichment service then quickly joins in customer, device, and historical data, so the risk engine never works with a half-empty context. Next, rules and ML models score the event under a tight latency budget, typically a few hundred milliseconds. An action service immediately approves, steps up verification, or blocks the request. Batch monitoring is where you mine historical transactions and identity data to understand behavior over time. On a schedule, heavy analytics jobs compute features such as payment velocity, structuring patterns, and peer group norms. From those, you generate scenario triggers that feed your AML engine or case management system. The trade-off is latency. You're not blocking a transaction in real time, but you gain richer context, backtesting, and the ability to detect long-running, subtle patterns. Designing the trust pipeline is largely about choosing a processing strategy. Real-time gives you low latency and strong fraud and sanctions control. But it's expensive and complex because you're making stateful decisions inline. Pure batch is cheaper and simpler, but too slow for anything safety critical. It's better suited to complex AML analytics and behavioral models. Most serious platforms end up hybrid: segment events, reserve real-time for must block now, and push everything else into smart batch processing. Alert generation operates like a narrowing funnel. At the top, rules and ML models fire aggressively. You want high recall here, even if it's noisy. The next stage enriches those hits with contextual data, then clusters and deduplicates them so multiple signals about the same customer or pattern are grouped. Finally, a prioritization layer orders alerts by risk and urgency. Architecturally, each stage is a separate concern with clear inputs, outputs, and tunable policies. Each alert should be treated as a routing problem, not just a notification. The risk engine scores the alert, and that score drives three different workflows. High or critical risk goes straight to auto-escalation. Immediate human review, tight SLAs, and strong audit capture. Medium risk alerts flow into specialized queues where analysts follow playbooks under time-bound SLAs. Low-risk alerts can auto-close when they match well-understood benign patterns, but those patterns must be constantly retrained from investigation feedback. A good AML case management system is your control room. First, it needs a flexible case structure. One case can group alerts, customers, accounts, and documents so investigators see context, not isolated events. Second, workflow states must be explicit and enforced by the system, not by spreadsheets or email. That's how you get consistent handling and clear SLAs. And third, every action must land in a compliance-grade audit trail, tightly linked back to verified identities. For AML and risk engines, everything orbits around a unified customer profile. This is your single authoritative view: legal identity, ownership structure, and baseline risk rating. Into that profile, you continuously feed KYC and enhanced due diligence data plus behavioral history such as login and transaction patterns. You also ingest prior alert history and sanctions decisions, and relationship networks like shared devices, IPs, and counterparties. Architecturally, every scoring or monitoring component should both consume and enrich this one profile. A strong AML program lives or dies by its feedback loop. Monitoring engines generate alerts, but the real value appears when investigators label outcomes as true suspicious activity or false positives and record why. Those decisions and rationales must flow back as labeled data into your rules and models. That labeled data retrains models, tunes thresholds, and updates heuristics. Over time, this loop reduces noise, sharpens risk detection, and aligns the system with investigators' real-world judgment. In a production KYC or AML platform, optimization means tuning rules and models together, not choosing one over the other. Rules give you precise, explainable levers, thresholds, scenarios, and hit rate adjustments that compliance can understand and defend to regulators. Machine learning manages the precision, recall trade-off, retraining on new data to reduce false positives without missing true risk. Your architecture should support safe experimentation, quick rollback, and side-by-side evaluation of rule changes and model versions. In a mature identity and AML platform, analytics isn't just reporting, it's a control surface. Operational metrics tell you whether the machine is running. Alerts per 1,000 transactions, average case closure time, backlog, and analyst throughput. These drive staffing, workflow tuning, and escalation design. Risk metrics tell you whether the machine is still calibrated. SAR yield, concentration of emerging typologies, and drift in risk scores or models. Strong architectures make these KPIs first class, streaming out of services rather than stitched together later. This blueprint ties everything together into an identity-centric monitoring loop. Raw events flow into both streaming and batch engines, so you can react in real time while still running deeper overnight analysis. Both paths feed an alert funnel that scores, deduplicates, and prioritizes what truly matters. Those alerts are enriched with unified identity context, turning transactions into customer-level risk views. Investigation outcomes then feed back as labels and new rules, continuously training models and tightening your controls over time.